Number 4 says to complete the table and graph the function. So if the directions say to graph using a table, it is the same thing. We are going to pick numbers in the domain or for the input or for values of x that we're going to plug into the function, and we are going to get out the value of y. For this particular problem, because I have the 1/5 x or the negative 1/5 x, I'm going to plug in numbers that are divisible by 5. When I plug in numbers in that are divisible by 5, I end up with whole number answers instead of fractional answers. So if we plug in negative 5, I'm always going to plug in 0 because that's a nice number, and positive 5. First, let's plug in negative 5. So we have negative 1/5 times, instead of x, we're putting in negative 5, or negative 5 over 1 plus 1. So nothing has changed other than putting the negative 5 over 1 in for x. Simplify this down. A negative times a negative is a positive, and the 5's cancel. So we just have a positive 1, because 1 over 1 is the same thing as 1. Bring down your plus 1, and we should simplify that to y equals 2. That gives us the coordinate negative 5, 2. We plot that on our graph, and we move on to the next value of x, which is 0. If we plug in 0, anything times 0 is 0, so we have 0 plus 1 is just 1. We plot the point 0, 1. And move on to the value of 5. We have negative 1/5 times 5 over 1 plus 1. This time, a negative times a positive is going to give us a negative 1 when the 5's cancel. And we see that y equals 0. So we're going to go plot the point 5, 0. Connect the dots. Now, one thing that you can do to verify that your graph at least makes sense for the equation is to ask yourself, does my line go up or down from left to right? You read a book from left to right, and you read a graph the same way. So from left to right, this graph goes down. That means it should have a negative slope, and it does. So the graph does make sense for this equation. Another thing you can look at is that this 1 is your y-intercept. Does it cross the y-axis at 1? Yes, it does.